Hi Astro Addicts, my name is Tim and welcome back to Astro Addict and welcome back to explaining PixInsight. In the last video we talked about the background modelization, getting the background even and removing some color cast and maybe gradients. Originally I would do the deconvolution now, but I found out that with a focal length this short, 450mm, the deconvolution is almost non-apparent. And I really don't want to waste 2 hours of deconvoluting for a change that is almost non-apparent. I will maybe do the tutorial on deconvolution later. It's a process that takes a lot of time, is very frustrating because it won't work most of the time and the change is almost not visible. And that is why I will now continue with the one-shot color workflow without deconvolution. We left off right here, the integration of the Horsehead Nebula. We did the background modelization and the background looks pretty much even. We have a tiny bit of color cast in the bottom left, a bit of brownish, let's see, this over here. We still have to get rid of that, but overall this looks pretty nice. The next step in the one-shot color workflow would be the color calibration and the first part of noise reduction. The noise reduction in the linear form. Remember, the image is still linear, not stretched. Alright, color calibration. It doesn't take a lot of time. PixInsight has a lot of great tools for color calibration. I usually only use one because the photometric calibration doesn't work for me. The plate solving doesn't work, but I will explain it just what it does really quick. We go into process and color calibration. We have 5 different tools. We already used the linear fit. We have assisted color calibration and the photometric color calibration. The photometric one basically analyzes, plate solves the image and refers to the catalog how the stars should look like. Very powerful, but plate solving never worked in PixInsight for me. It's awful. You could do the assisted color calibration. It's basically only moving red, green and blue. But I like to do the color calibration because it samples the background and the stars and aligns the colors. Very easy. Before calibrating the colors, we need to neutralize the background of this image. We have the background neutralization tool in the same subcategory here. And now we have to create a good preview for the background. And you can see the background is not really even in this image, so we will create multiple of those. And I will try to catch areas with least amounts of nebulosity. I always create a new preview over here with this button and get this area down here as well. Maybe over here. And on the Horsehead, no, I don't think so. Over here, there. Now you can see, the problem now is you can only put one preview in this window, but there is a script called Preview Aggregator Script. I put this little just to remind myself. It's the cosmetic correction. The script, I'm sorry. Utilities and Preview Aggregator. It now takes all the previews I just created and puts them into a single image. Nice, and now we can use that one. Normal stretch please, and normal stretch on this one. Add the aggregated preview, it's called aggregated, and apply. The change is almost non-apparent. The background is already pretty good neutralized from the linear fit and the background modelization. And now we can go to color calibration. The white reference, you can pretty much leave this to default because it samples the stars. That's what it's supposed to do. And the background reference is the aggregated preview again. Now let's see if this changes anything big. Takes just a couple of seconds. I think it did something. I hope it hit something. You can see the flame nebula. Let me zoom in. It gets a little bit more yellow-orange tint. Now it has a reddish, maybe a bit of pink. And if I redo, it has its nice and almost orange-yellow burn to it. and the nebula itself gets a bit more red and less pink or magenta, let's say. The stars themselves, I don't think that Ornitharc is a good reference for anything, because it just blurred out. It's got a little bit greenish maybe, but I don't think that's a problem. We can work on the star colors later. But overall in this image, this change is pretty good. Some of the bright cast disappeared, which created more contrast from the left side here, which is not necessarily a good thing, but we can get rid of this later. That's the color calibration, pretty easy. And just one more, I will keep this preview, it can always come in handy. One more information on the photometric color calibration, because I've heard that many people use it. I don't know why I don't get to make it work. The plate solving just doesn't work. I get an error every time. But I did read a book about PixInsight, and I will leave the information about this process down below. It said that the most important thing in the photometric color calibration is to tell the software what object you're photographing. So you can see the white reference here. It's either all types of galaxies or the stars. I think what was the sun again? G2V? I don't think I remember that correctly. I will leave some information of what you should choose here according to your image in the description below. I will just take it off the book. And maybe that's some handy information to you if you want to use the photometric color calibration. But it doesn't work for me, I don't know how it works. Alright, the color calibration is done. Looks good. And now the first part of noise reduction, the linear noise reduction. Usually in the one-shot color processing you have two stages of noise reduction, one when the image is still linear and one in the non-linear state. And for the linear noise reduction we use a tool called Multiscale Linear Transform. The one right here, you can find it always in the process window, and I think it's down here. Multiscale Linear Transform. Now the background of multiscale processors in PixInsight. Many processes in PixInsight use something called Wavelet Layers, and that's a very important thing to know what wavelets actually are. And I think I can visualize it pretty good at this image. I will delete these previews, we have the aggregated one. Imagine you can break your image down into layers, basically. Layers of different structure size. So let's say we can break this image down into layers of 3. The lowest layer would have the structures that are the smallest, the noise basically. And the uppermost layer has most of the nebula and stars, because these are big sized objects. And I think there's a script somewhere here. I did not plan this noise reduction. No, let me take a look. I just found it. If you go to image analysis and extract wavelet layers, you can now say how many layers you want to extract. Usually a number between 4 or 5 is good. And the so-called residual layer is the uppermost layer, the layer which you usually can't edit. It's called residual R. And here they are. So let's take a look at the bottommost layer. The layer with the smallest types of structures. And here you can see it. Most of this is noise. Maybe some cores of the stars which are bloated out, but most of this is noise. And the second layer, structures that are a bit bigger. You can't see noise, but you can see, again, some stars, but not the cores. Not just the cores. And the next layers have increasingly sized objects. And soon we can see something like this. And these are the biggest structures in this image. And you can't see any noise, because the noise has been separated through these wavelet layers. And we can use these layers in noise reduction to separate actual data we want to preserve from the noise we want to smooth. And that's what the multiscale linear transform is doing. The algorithm is usually multiscale linear transform. You can use the other one, the Starler transform, for sharpening. And you can see layers right here. Layer 1, the smallest, the one which you want to smooth out the most. I usually go for 4 or 5 layers. And now I will, most importantly, the target is the luminance, the entirety of the image, not only the color channels. And now we can activate noise reduction for the first layer. The threshold is usually something about maybe 10, and always try to work back and forth and see if you like the change you just did. The amount of 1 is pretty much. Iterations, let's turn up to 2. You can use a mask for this one, and I don't tend to use the linear mask feature. I like to create a custom mask, but I don't think it will be necessary because the object itself is pretty... You saw most of the object in the residual layer and not in the other layers, so I don't think it will be affected that much. I will create a small preview, maybe over here. And you can see noise in there, yes. And let's try this. Let me now press before and after. Not that much of a change. No change at all. So maybe layer 1 is actually too small. Let's do the same to layer 2. A threshold of 10, increasing the threshold will remove more structures, will smooth out the image much more. Again, go to 2 iterations and try it out. And there's the difference. You can see the stars have been affected a tiny bit. They are blurred out a tiny bit. If you want to preserve those stars, you will have to apply a mask. A custom star mask, for example. And I will try to explain in a future video how to properly use masking in PixInsight, because it's pretty powerful. I don't think that I like this change that much because the stars have been affected way too much. 6, and let's do more noise reduction on all layers. You can't do noise reduction on the residual, but with a decreasing amount and threshold maybe. Let's just try that. I will go to the full image again and apply. And this is really back and forth. See if you like the change, see if you don't like the change. You can see the horse head has been smoothed out a lot. But this is actually pretty good. Well, the harsh edges definitely disappeared. But that's the thing. If you remember, we looked at the wavelet layers with the script, and the outlines of the horse head were in the layer number 2, I think so. Let's look at it again. We can use this script pretty often, and it's pretty nice. Where was it? Please give me those. I think it was in layer 1 or 2. You can see the outlines of the horse head are in layer 2 and layer 1. And the sharp outlines are in layer 1. But we saw that affecting layer 1 did nothing for the noise most of the time. Let's get rid of these again. I can make them again anytime I want. So let's try to preserve this detail either in the tool itself or apply maybe a mask. If we disable layer 2, what does that do to these edges? Again, they are gone. Disable layer 1. You can see that layer 1 has an effect also on this part, but not the preview, really? Well, now it has an effect. Great. Alright, let's maybe use a mask to protect the brightest stars and the nebula. We'll go into process and go to range selection. Where is it? Over here. Now usually when I create the mask, creating a mask from the linear image is pretty annoying because, let's try it out, the real-time preview. I increase the limit just a tiny bit and the data is gone. And that is why I usually clone the image. I will apply a stretch, a non-linear stretch. We will talk about stretching later in the next video. But now this image is non-linear and we can apply a much easier and smoother result for the range mask. I don't want that much, but I want to preserve the horse head. Really want to preserve the horse head. So maybe this one. Drag and drop. And now, and I will talk about masks again in another video. Take this one and drag it down here. This rendering mode is awful. I like to use replace. White selects, dark protects. Good to keep in mind. Get rid of this one. And don't show the mask, but it's still enabled. And try this tool again with layers 1 and 2 enabled. And maybe decrease the threshold in these upper layers. Now the thing is, most of the background will be affected, but nothing of the nebula we just saw in white just here. So there could be contrast and noise, which doesn't always look good. You can see this part right here, super noisy, but no noise up here. But it will fade out into the noise, which is not necessarily always a good thing. But the corners of the nebula are still there. Point 1. And this is basically what you have to do in the first stages of noise reduction. Go back and forth, create multiple masks, and see if you like the change. I usually don't go for such a harsh mask that you saw right now. These sudden changes in noise are pretty apparent even for non-photographers, let's say, and they can really get a hard time editing afterwards, make you a hard time editing afterwards. So try to get a smooth result, don't affect anything of the actual data. Horsehead, flame. You can affect the small stars a tiny bit, those will get transformed away either way in the end. When we shrink the stars, a very powerful tool in PixInsight, and my favorite tool in PixInsight. But that's the whole point. Don't try to affect the nebula. A nebula is supposed to be smooth, but it's not supposed to be smoothed out even more. You can see the nebula here is super smooth. There are no sharp edges, just slow bulges of hydrogen, which looks awesome. But if you smooth them out too much, they just really fade away and lose contrast, which is awful. And again, these harsh edges of contrast. Creating these masks for the Horsehead Nebula was a challenge in the original image, but I think I got it down after a few tries, and that's it. Make a lot of tries, go back and forth, and look at the before and after, see if you like it. Alright, this has been the color calibration and linear noise reduction. The next video will be the stretching. I don't think that the stretching video will be that long. I will go through maybe. PixInsight has a lot of tools on which you can stretch the image, but I usually go either for the basic screen transfer function or the masked stretch, which is pretty awesome for galaxies, but not necessarily for the nebulae right here. But I will explain it nonetheless. So let's close this down, get a nice clean surface, get the previews away. And let's take a look at the before and after. I don't need the clone anymore and the mask. Usually you want to keep most files in the project, but this project will be very big. I remember the drizzled up version of the 4-panel Hard Nebula mosaic image. The project file was, I think, 30 gigabytes each time. Oh, awful. You can always make mask. You can always make the mask again. You can also downscale it to 8 bits. It works just the same. Let's look at the before and after. We modelized the background, and now we have applied the last bit of noise reduction before the stretch. This noise reduction is not perfect. I will try to work on it even more, and you should work on it until you like the result. And as for me, my name is Tim, I'm an Astro Addict. I wish you clear skies, and may the night be with us.